Hey everybody, Tommy Clayton here to share a little bit about lesson 4 from unit 8.3, the forces at a distance unit. The first couple times I taught this lesson, I made some mistakes. I went into this really thinking that I needed to really show the kids a lot more, and didn't quite realize that it's okay that we don't have the full view of what's happening with the magnetic field in every investigation, because in the end we go to a simulation and we kind of put it all together. So excited to talk through this lesson with you and help you not make those mistakes, and really see the progression of how students are figuring out what's happening around the magnet in that space. So we're going to look at how we got into this lesson, take a look at this lesson at a glance, talk about some of those key moments, and then help you out with some of the material management and give you some tips and tricks. So let's dig in. All right, let's remind ourselves how we got here. So we're coming off of lesson 3. Lesson 3 was a short investigation to figure out that the air has nothing to do with the way that magnets can transfer energy. In fact, it works when there's no matter. We saw it work in the vacuum. So this lesson, we're really like, well, okay, so like what's happening in that space, right? We need to figure out more about that. And so that's what we do. So let's take a look at this lesson at a glance. This is a 4-day lesson. It's an investigation lesson. Material prep's pretty short, just about 20 minutes. There is lots of hands-on investigation, and students are going to need some access to a device. There's an interactive at the end that they take a look at. And there is a magnetic field setup video. There's also an optional video if you want to create an additional magnetic field video. We'll talk a little bit about that later in the video. All right, so let's take a look at this lesson at a glance. So the first day, there's a chunk of the lesson that it takes up most of the day. And then that leads us to the navigation. And so the next chunk is going to happen over the end of this lesson into the next one. And in this first chunk, the students really figure out that there is a particular shape to the magnetic field, to that area around the magnet. And then we're going to navigate and think about more about that particular magnetic field and its shape and like what could be happening there. And so we're going to use some compasses, and ultimately we're going to figure out that there's actually like a direction to it, to the forces in that magnetic field. And so similar to the last lesson, big chunk over the lesson, and then the navigation sort of leads us into the next day, where we finish up this last chunk. And that's where we take what we've sort of figured out using the permanent magnet, that there is a particular shape and it does have direction. And we apply that to the electromagnet until we figure out the same thing, that the field around the electromagnet looks pretty similar in terms of shape, and it has a direction to those forces. So on the last day, we kind of put it all together when we use that simulation, and we add one more piece to it, which is that the forces actually get a bit weaker as we move away from a particular magnet or coil. So this is where the kids get to see the simulation and really get to picture more of what that field looks like, and get an understanding of that relationship between the force and the distance. So we're going to figure out that there is a 3-dimensional shape around the magnet, and that's called a magnetic field. We're going to spend a lot of work defining that in this lesson. And we're going to test a bunch of different objects to show us that magnetic field. So we're going to use iron filings, compasses, and we're going to do that with the coil. And then we're going to use that simulation. We also figure out that the electromagnet has a magnetic field, and it's similar to that of the bar magnet or the permanent magnet. So let's take a look at a couple of key moments here. The first is part 2. We're going to investigate the field around a magnet, and we're going to start to see some like patterns in the iron that's around that. Okay. On the screen is an image of the simulation they use at the end. And it's okay, again, if they're not totally seeing it perfect like we see it in the simulation. That's going to be there for you at the end of the 4 days. So it's okay. All we really want kids to see is that there's some type of pattern, seems to be 3-dimensional, and there's something going on with the ends of the magnet, and there's some curves and things like that. But again, doesn't need to be perfect. We don't need to draw it. We just need to see that there is, in fact, something happening around the magnet. In part 7, that's when we test the magnetic field using the compasses. And this is where we want to see that there is direction. Again, we're going to draw here, but again, doesn't need to be perfect. All we're trying to really focus on is that it seems to be pointing out from the north and in toward the south. And we want students to draw the direction of those forces using the compass. Then in part 11, we're going to test the wire. We're going to use thicker wire this time, and we're going to stretch it out so that it takes the shape a little bit more of a bar magnet. We are going to help the kids to see that it is still a coil of wire, but we're going to stretch that out. We're going to do the same thing. We're going to use the compasses, and we're going to notice that we see a similar pattern, that all the compasses point in toward one end of the coil and out from the other. And we're going to draw that again to get those directions of the forces. Then finally in part 15, this is when we get to use the computer interactive. And so this is where we get to really see a nice, perfect, beautiful magnetic field. Again, we've seen bits and pieces of it, but this is where we really get to see it. Students are going to get to move that magnet or coil around. They can select either, they can flip it around, do all sorts of cool things. And all those little triangles represent compass needles, which we've been using, so it should be pretty familiar to the kids. The one big thing you want to focus on is get the kids to move the magnet all the way to like the corner of the screen or, to the edge and look at the stuff on the other end. We want to really focus on what's happening with things far away, because what we're trying to get them to see is like that the field is not necessarily as strong, still has an effect, but not nearly as strong when things are further away. Still some movement, but much less than the compass needles that are very close to that particular magnet or coil. Okay, so where we go from here is in the next lesson, we're like, well, what if we put another magnet or a coil next to that? Like, what if we add one to the system? How does that change the magnetic field? So in lesson 5, we're going to play around with the simulation, check out some cool things with 2 magnets or a magnet and a coil. Okay, so let's talk about some tips and tricks for this one, because there's a couple of things that are happening in here you want to be prepared for. The first is that part 2, there's a great setup video for getting this all set up. This is a teacher demo. If you have the stuff to do it and you can get the kids to do it, awesome. You're going to want to make sure that the magnet stays sealed in that bag. Double, triple, quadruple seal it so that the iron filings can't touch the magnet, because if they do, it's a mess. Okay, so you want to really make sure that that is happening. The iron filings are going to end up going, it's hard to tell in the picture, but the magnet is in a sealed Ziploc bag. Then we place a plastic container on top and then sprinkle in the iron filings. And so the iron filings are not directly in contact with that magnet at any time. You're going to want to put white paper underneath if your tables are a darker color to help the kids really see that. When you are sprinkling in the filings, you want to give the container some gentle taps. That'll help the filings sort of like fall into place. At any point, you can kind of lift the plastic container away from the magnet, let them sort of like reset, shake them a little bit, tap them a little bit, and then put it back down. And that'll help the kids to see things sort of like fall into place. You'll probably get some great like, ooh, moments. Really cool stuff. This is super important. So in part 7, they're going to use compass, either needles like you see on the screen, or maybe small little compasses. The first thing you want to do is set all your compasses out on your lab table and make sure that they're all pointing the same way. You'll notice in the picture that some of these have flipped. They can flip orientation if they're stored near a magnet or some type of magnetic device for a period of time. So you just want to like separate those. All we really want to make sure is that kids get all of the same compasses, that they're all pointing the same way. Because if they don't, when they're moving the compass around the magnet or the electromagnet, they're going to get some weird results. So just take a look at all of them, set them out, make sure that they're all facing the same way, then sort them. The students can also do this with just one compass. They can move that compass around. There's images on the slide that show them the positions to move that one compass around and draw it. It is much cooler if they can see a bunch of compasses around that. So if you don't have enough for every student to have several compasses, you can set up a moment where the kids can come see them all around after they've used one to kind of like draw that out. Okay. When you're putting the compasses away at the end, be mindful of storage. Again, don't put them near your magnets. Don't put them in the same drawer. Help to keep them away from things so that they don't get flipped in their orientation. We're going to add some words to this word wall, particularly magnetic field. We work really hard to define this word, and we earn this word. It's going to take us the better part of the 4 days to really earn this word. So we're going to introduce it in lesson 1. We're going to name it. We've been using it probably, and we're going to add a working definition in part 4, but we're going to go back and revise that again in part 12. So there's some guidance in the teacher guide to help you with that. We are also going to officially encounter north and south poles of the magnet and compass, add those to the word wall, and that's in part 7. There is an optional reading for students to learn more about the Earth and magnetic and geographic north. Fun fact, geographic north is actually magnetic south. Blows people's minds, including my own. And kids might even realize that when they're working with the compass. And so that's in there as well. It's an optional extension. There's time in lesson 5 to go over that if you want. No posters. All right. Nothing to prepare for this lesson in terms of posters. And that's going to do it for us. Come back and check out lesson 5. That's a nice short 1-day lesson where we get to investigate what happens when there are 2 magnets in the system. Thanks everybody for watching. We'll see you in the next video.